Occultation light curves. This is a new initiative, and I think it's an important initiative. I'm pushing people to get involved in this. We can go to the next slide. Occultation light curves. I've done 2 uploads now. It's on Vizia as catalog B/OC. You can query the archive using a star identification number, observer's name, and a whole heap of other things. You can plot the light curve, and there are now 2,060 light curves on Vizia. And I would encourage anyone that records a light curve to actually submit it for archiving. Yes, I see, you can hear and see me. I can't hear me, and I can't turn me off. Next slide. This is a screenshot from the plot that you can get out of Vizia. This is an occultation light curve. I'm not sure who actually recorded this light curve. You need that on a different page. But you can see the type of plot that you get, and you can play around and do all sorts of interesting things with the graph. One of the good things about this is if you get a light curve of an occultation which looks a bit funny, then you'll be able to go into the archive to see if anyone else has got a light curve which has a similar look of funniness, and then you might think, oh, there's a double star involved, or Fresnel diffraction, or whatever. Gives you more information. Next slide. Why are we doing this? A video recording at 30 frames a second easily attain an angular resolution of 0.01 seconds of arc in a lunar occultation, and that's at least 50 times greater than the resolution provided by a normal telescope, and it's better than the Gaia resolution. Therefore, video recording lunar occultations actually provides a tool for surveying the size and or presence of companions along the ecliptic at a resolution of around 0.01 seconds of arc, band 11 degrees centre on the ecliptic. And we don't normally think of occultations in that sense. Next slide. Now, a bit of history. Prior to about the year 2000, almost all lunar occultations, and asteroidal for that matter, were made visually. And the objective was to determine the time of the event and nothing else. If you saw a fade, well, you'd record the fact of a bit of a fade, but it was a bit of a nuisance. If you saw a step event, you'd try to estimate how long the step was, but you didn't really have a good means of measuring the step. Historically, lunar occultations were used to measure the irregularity of the Earth's rotation, and asteroidal occultations measure the size and shape of asteroids. Next slide. High-speed photoelectric observations of lunar occultation have been made since the 60s. The number is small and use large telescopes. I mean, you're looking at 30-inch plus telescopes generally. The photoelectric observations discovered double stars, measured stellar diameters, and in fact included light distribution across large stars such as Aldebaran and Antares, and they had to deal with Fresnel diffraction. Next slide. For many years in those early days, video was analysed visually by video playback, frame by frame viewing. Some people, most notably in Europe, converted individual frames into FITS files and used traditional CCD imaging tools to conduct a photometric measurement of the star over a series of the FITS files. But in all of that stuff, the focus remained on establishing the event time and not the light curve. Next slide. I've got quite a bit of history on this, by the way. Around about 2005, we had iMovie come on the scene. It was the first tool that enabled simple but reliable measurement of video. We also had the Kiwi OSD to reliably insert a GPS time-based timestamp on videos. And then we have Tangra, second tool for measuring video, focused primarily on asteroidal events. And then the IOTA VTI, a replacement for the Kiwi OSD, which was withdrawn from sale for reasons I won't go into. Next slide. By 2010, video recording of occultations using time insertion become the norm. Occasionally people noted steps in light curves measured by iMovie and Tangra. We developed a system to report and analyse double stars measured or discovered that way, and those reports go to Brian Loader in New Zealand, who publishes stuff regularly in the Journal of Double Star Observations. However, many stars previously reported as double by visual observers don't display step events on a video measurement. Many showed gradual events consistent with Fresnel diffraction or stellar diameter, not double stars. Next slide. The important issue with double star observations is to be able to combine multiple measurements to derive a solution for the position angle separation. There have been several instances where an old video recording of lunar occultations is being measured using modern tools with a light curve showing a step event. I remember getting a double star recording a couple of years ago and then looking in the lunar occultation archives and realised that, I forget the person's name, lives down southern states in a caravan. But he recorded it by video about 2003. He pulled out his old video recording and we measured it, and he had a double star event in his old recording. And we were able to solve for the double star parameters. We're up to 7 now. Recently, the Kepler mission came to an end due to the failure of gyroscopes required for pointing that satellite. However, they figured out a way that they could observe areas of the sky along the ecliptic for about 3 months at a time, using the 2 remaining gyroscopes in combination with the solar wind. And that mission is called K2, not Kepler 2, it's K2. And a researcher involved with K2 noted that occultation light curves of target stars could be very useful when analysing K2 results. Next slide. And this just shows the locations of the K2 fields along the ecliptic. They'll slowly cover the whole ecliptic in time. So, next slide. Basic principle. Now, it's a new way of thinking about what we do. To maximise the value of the video observations we make at great cost to our time and wallet and everything else, we need to archive the light curves we record. It's not just a matter of getting a time out of it, there's more to it than just time. Archiving makes the light curves available to all for future investigations. And it's important to remember that a light curve that does not show a companion is not proof the star is singular. It may have a companion in an elliptic orbit, and a light curve that does not show a companion may still be useful when determining the orbit, when later on you get a light curve which shows the companion. Next slide. Vizier is the logical place to archive this data. They've been very keen and supportive of us archiving light curves. They've assisted in developing a format for submitting the light curve, and I'm hoping that the process I've put into Occult for reporting observations has been made as simple as possible. And LiveMovie has been updated to facilitate transferring light curve data to Occult with its copying the data. Tangra already had the required capability. You'll like, well, what I've got in Occult is essential because it's not just the light curve that you need. There's a range of other parameters that you need for lunar occultations. It's all the lunar librations, position angles, rates of motions, a range of other data. For asteroidal occultations is not as much data, but extra data in there. You need to provide that with the light curve. So you need to report the light curve from the Occult environment, not just here's a file. Next slide. I'll just quickly go through what's involved with reporting a light curve for lunar occultations. If you record a lunar occultation, you'll go through your light curve, you'll get an event time, which you report in the lunar occultation reporting form in the normal way, entering the time and various other bits of data. After you've entered the observation, well, that's what's showing up on the screen has come up different to what I've got on my screen. After observation is entered, make sure the observation entry is highlighted on the events screen, then click the menu item at the top, Light Curve Report, Create Light Curve Report. Next slide. Occult generates all the information required to support the observation. All you need to do is to copy the light curve as a CSV file from LiveMovie, and there's a button there in the latest version of LiveMovie, Copy CSV, that's from the LiveMovie form, or from Tangra, and paste it into the report. There's their file, paste CSV data. And you finish up with some data at the bottom of the form, that's just a screenshot of an instance there. You see the type of data which is included. Various star numbers, observer dates and details, and the circumstances. Next slide. This is as part of the light curve reporting tool. You paste the light curve in, you'll have the light curve displayed, and then what you need to do is select the portion of the light curve to actually be included in the report. So here, the highlight, the region in green, will be included in the report. You select the start and end, you can adjust it. The light curves are all scaled to be in the same scale range. And once you've done, you click OK somewhere. And next slide. Click Save this report to save it on your PC. Periodically click Email Multiple Saved Reports from the Lunar Occultation Report Generator to submit them, and Occult will periodically remind you, with the default reminder being 1 month. Next slide. For an asteroidal occultation, from Asteroid Observations tab, click Light Curves Report. So that's the main tab in Occult. And there's a button there on the right of Light Curves Report. This will open the Light Curve Report form with some changes specific to asteroids. Next slide. First step is to paste or open the Light Curve Report, and the second step is to click Set Event and Observer Details and then enter the details. And next slide. These are the details which you need to fill in. There's a date, asteroid number, the name should get automatically populated, your site coordinates, which you can set as a default to use on, if you're observing from home, you can keep on using the repopulate with your own site. On the right hand side you select the star, and if you, depending on the star, you then go off and query Visio to get some equivalent stars to fill in Hipparchus, SAO, or Tycho, and then last bit you do is click the transfer data and exit when that's done. And next slide. For the actual light curve, you select the start and end of the segment of the light curve to be reported as per lunar occultations. However, the light curve will usually be much longer, and for asteroidal occultations, remember the statistical issue of dealing with noise. You might need to record quite a lengthy bit outside of the occultation, particularly if you've got a low signal to noise event. The save is as per lunar occultations. The light curve will be saved in the same location as lunar light curves and submitted in the same manner as for lunar light curves. Next slide. Within Occult, the light curves are a download in Occult. Light curves can be viewed by star number. In lunar occultation prediction, stars of the light curve available are flagged. The light curves can be viewed via the right-click menu. Currently, well, as of yesterday, there are 2,060 light curves available at Visio. And that's it, basically. Last slide there. From my perspective, us moving to a position where we recognise value in the light curves we record and have them archived is an important step forward in recognising the value of the observations we are making, and we ought to change our habits to routinely report every light curve we get which shows an event. Happy to take questions.